Hi there. Um, Enough kids are having some challenges with this that I really wanted to make sure there was a video out there to show how place value charts can be used to show what multiplication means. In addition to that, I'm just excited to have my small graph paper back. So let's go ahead and take a look. If we were doing a multiplication problem such as, let's say we're doing 2,534, and we're going to multiply that times 4. How's that going to look? The kids are being asked to show this in 4 different ways. The same math problem, just 4 different ways. The first place value chart is going to show what partial products look like, which I went over before. If I'm going to do 2,534 times 4 using partial products, I'm going to do 4 times 4 is 16. Instead of regrouping it, I'm just writing it as a 16. Once I'm done with the ones place value, I move on to doing my factor times the tens place. 4 times 3 tens is 12 tens. While I could just write the 12 so it's floating in the tens place, mathematically, we always want that 0 that a 10 will have, so it looks like 120, the number it's meant to be. 4 times 30 is 120. The factor times 5 100s, we just think of hundreds needs 2 zeros. 4 times 5 is 20. And then we get 2,000 when we look at it as an entire number. Then we do our factor times the thousands place. 4 times 2 is 8. I need 1, 2, 3 zeros for being in the thousands, and then an 8. Some kids get confused and say, Mr. Kodva, this was 100, but it has 3 zeros. Remember, these 2 zeros are from being in the hundreds place. This 0 comes from having gotten a 20 by doing 4 times 5. Whereas these 3 zeros came from the thousands place. The only thing I got from doing 4 times 2 was an 8. No extra zeros or extra digits. Once I've got all these partial products, I put them together and do my addition. 6 plus all those zeros is 6. 1 plus 2 is 3. 1 plus a bunch of nothing is 1. 2 plus 8 is 10. I could regroup that, but it's just going to come back down here anyway to me 10,135 or 36. Now, on a place value chart, that's going to look something like this. Our place value chart is comprised of 5 spots, because numbers can have any number of spots. We're going to use 10,000s, thousands, hundreds, tens, and ones. If I am going to do 2,534 times 4, I'm going to use my place value chart to show each of the pieces of the 2,534. What I mean by pieces are, we call it expanded form when we do it in school. 2,000, so I'd write the 2,000 out as 2,000. 500, write it as 500. 30, so I write it as 30. 4, and each one is in their respective place value. Now the thing is, this is really just a math problem of 2,534 times 1. I'm going to need it 3 more times in order to be times 4. Once you have it all written in there, you can see I've got 2,534 and another 2,534 and another one, so I'm doing it 4 times. Once I've got that, I can add up all of these place values and see what I've got. 4 plus 4 plus 4 plus 4 is 16, and obviously think of that as a 4 times 4 if you'd like. 30 plus 30 plus 30 plus 30, 30, 60, 90, 120. Again, 3 times 4 is 12. Put a 0 on for being in the tens place, 120. 500, 1,000, 1,500, 2,000. And then finally, 2,000, 4,000, 6,000, 8,000. If these numbers are looking familiar, it's because they're the same products that we got when we did our partial products. These partial products, we're still going to find our final product in the same way by adding them together. 6 plus all these other ones places just gives me a 6. Tens, 2 tens, 1 10, that's 3 tens. No hundreds, 100, no hundreds. And then 8,000 plus 2,000 is 10,000. And I get the same 10,136 that I got before. So the first way that I do these together. I have a place value chart showing expanded form. It tells me my partial products. I do a math problem, and instead of regrouping, I give partial products by showing the answers for the factor times each of my place values. This one is by doing my ones place, which is 4, times my factor of 4. This one is my tens place, which was technically a 30, times 4. This one is my hundreds place, which is a 500, times a 4. And then this one is my thousands place, which is 2,000, times a 4. Hopefully you can see the only difference between these is the fact that the 2,000s are piled up in a row on a chart versus doing it here. Obviously this would be a better way to do it because it's smaller, but we want to understand that these and these are the same thing. Now, the other way of doing this is with regrouping. Now, if I want to regroup, we usually do our place value chart with some symbols. You could use place value chips if you had actual physical manipulatives. We're drawing pictures. It's 2,534, so I'm going to put some pictures in to be my 4. 1, 2, 3, 4. And some pictures in to be my tens. A $10 bill is different from a $1 bill, so I'm going to use a different picture. Triangles for my tens. I've got 5 100s, so I'll do 1, 2, 3, 4, 5 hundreds. And then I've got 2 thousands, so I will do 1, 2 thousands. Again, I've got 2,534, but that's really only times 1. I need to have 4 in each column in order to be 2,534 times 4. Once I have 2,534 times 1, 2, 3, 4 groups, I can go ahead and start regrouping just the same way I would if I was multiplying here. The fact that kids already know and then can't really apply is that you need to take 10 things and trade them in to get one thing. In this case, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 circles in my ones place out of 4, 8, 12, 16. I can take 10 of those and trade them in to give me a new 10. And that's going to come over here. How I ask the kids to draw it is to give me a new symbol that's colored in black that goes with my regrouping. Now, how does that go with our math problem? Just like I have got 4, 8, 12, 16. If I do 4 times 4, I get a 16. I would write down a 16 by having a 16 here, but I don't want to write that down. I'm going to take 10 away from the 16, so I've got 1, 2, 3, 4, 5, 6 left over, and then take that 10, trade it in for one new 10. Now, there's my one new 10. Now I've got 4 groups of 3 tens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 tens. And then I've got one more that I regrouped, which gives me 13. Just like the regular way of doing 4 times 3 is 12, plus 1 is 13. Again, I want to write down that 13, but I can't write down 2 digits, so I write down just the 3, take away 10 from that, so I've got 3 left. The 10 that I took away gets regrouped over here for a new 100. And the way it's going to look over here is I'm going to take 10 of my 10s, and I'm going to trade them in to get one new 100. This new 100 that I just made correlates to that one new 100 that I regrouped from having a 13 here. Now you may be saying, how do I have 6 left? I've got 1, 2, 3, 4, 5, 6. Got 6 there. How do I have the 3 in the tens place? I've got 1, 2, 3 left in the tens place, so I got a 3 for my answer. Next, I've got 4 times 5 equals 20, plus 1 is 21. So I'd write down the 1, regroup that 2, because I'm really taking a 21, taking away 20 from it, and getting 2 new thousands when I trade them in. How does that look? I take a group of 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and trade that in for a new 1,000. And then I take another group of 10, trade that in for a new 1,000. I'm going to have only 1 left, just like the one that I had here. Finally, I've got 2, 4, 6, 8. 4 times 2 is 8, plus the 2 that I just regrouped. 4 times 2 is 8, plus 2 is 10. I'm going to write down the 10, write that down over here. Technically what I'm doing here is I'm regrouping all of these thousands and trading them in for 1 new 10,000. So I'll have 0 thousandth left and 1 10,000 here. 10,136, same as 10,136, same as 10,136, same as 10,136. If the kids are having trouble, absolutely, have them do this math problem first. That's the one that's the most common. Have them do this one second. We've done this partial product several times. See if they can do the expanded form so that they can take the expanded form version and compare it to this partial products where we're doing it as a math problem. And then finally, draw out their symbols and see if they can do the regrouping. If they're having trouble with this, that's fine. This is hard. There's a reason we don't do this, and we do this instead. We'll work more on this in class if they're having trouble with it, but really, this is just the visual representation of the regular regrouping algorithm. That's it. Hope that helped everyone. See you tomorrow.